Alrighty, guys. So we are looking at the first day of patterns. All right, so we're at the very beginning here. So welcome. I'm going to do this through Cami. We're going to quickly look at the warm up first. So this is all about recognizing patterns, and those patterns may be with numbers, they may be with letters, could be with pictures, it could be with a graph, a table. It doesn't really matter. So on this first one, you guys just had to determine the next three terms in the sequence. And after looking at this, in class, we determined that these must be the first letters of the months of the year. So after June and July, we have August, September, and October. Number two, we realized that these must be the first letters of the days of the week. So that would be Thursday, Friday, Saturday, if we're just looking for the next three terms, right? 5, 10, 15, 20, we realized that these were the multiples of 5. So it looks like we're adding 5 each time, 25, 30, 35. And then lastly, kind of cool here, a couple different ways you can look at this. It looks like you're subtracting 19 and then subtracting 17 and then subtracting, that would be 15. Yes. And then ultimately what we saw in class here was that, okay, if you want to continue on, maybe you're subtracting 13 and then subtracting 11 and then subtracting 9. Now this is what's called a second common difference. You're going to look at this a little bit closer in IM2. But if you see, there's a second common difference here where now the difference of the differences, you're subtracting 2 each time. So that's the way the majority of people saw it. But another way is that these are actually the perfect squares. So the square root of 100 is 10. The square root of 81 is 9. The square root of 64 is 8. The square root of 49 is 7. And the next terms would have been 36, 25, and 16. The square root of 36 is 6, and so on. So if you got 36, 25, and 16, you're in good shape. A couple of different ways to have noticed that. That's the cool thing about patterns. We all kind of see them in different ways. Now, these are what's called diamond problems. What we notice in class is that the two numbers on the left and right must multiply to get the top number and add to get the bottom number. Otherwise, there's no really rhyme or reason here. We're going to use this as a factor in IM2 later on. But for right now, we just want to see if you can pick up that pattern. So it looks like it works here as well. Check, it works. So if we look at these two numbers, well, what would the top number be? We would multiply to get the top number, so it must be 35. We would add to get the bottom number, so it must be 12. Now, this one's a little bit trickier because you are not given the two numbers that you need to multiply and add by. But if you kind of look at this, you can start thinking about, okay, what are my multiples of 72? And we determined in class fairly quickly that, well, this must be negative 8 and 7 because negative 8 times 7 gives you negative 72. And I'm realizing now that I made a small mistake. It's not negative 8 and 7. It's actually must be 8 and negative 7. And the reason for that is 8 plus a negative 7 gives you positive 1. Negative 8 plus a positive 7 would have given us negative 1, right? So those are your diamond problems. Let's work our way down here. So for number 1, we are looking at this thing pictorially. Okay, so this is given to us pictorially. Now what we determined here in class is that we have 6, 6, 6, and 6, and then there's 1 in the middle. So there were 25 total dots here. And then we had 5, 5, 5, and 5, and 1 dot in the middle there. So that ended up being, what would that be? Sorry, I think that comes out to 21. And then we had 4, 4, 4, and 4, and then 1 dot in the middle. So that came out to 17. And then 13, and so on. So for part A, when it asks for you to describe the pattern, there's a couple of different ways you could describe this. So one way some students said was, it looks like we are taking away a dot from each side every time. Some other students said, it looks like we are taking away 4 total dots each time. And those are actually both correct, right? It just depends on how you're looking at it here. So for B, it says draw the next 3 patterns. And if you continue to take away dots from each of the 4 sides each time, lost track here, sorry. If we continue to do that, we would probably have, let me get that drawing tool back, sorry. We'd have a 1 dot, 2 dot on the bottom, 1 dot, 2 dot on the top, 1 dot, 2 dot on the right, 1 dot, 2 dot on the left. Sorry, that's a little bit sloppy. But then this guy right here is going to be that middle one, right? So then that right there, if we continue with the total number of dots here, if we add those up, that'd be 2, 4, 6, 8, that would be 9. And then if we continue on, let's keep on going here to the next one, we would have a dot, a dot, a dot, and a dot. And then we still have that green dot in the middle, right? So that would be now 5. And then lastly, you can imagine if we take away each of those blue dots, then we're just left with that one single green dot in the middle, and that would just be 1. Okay, so if we are to draw the next 3 patterns, it's a little bit messy, but you can see here is the pattern for 9, here is the pattern for 5, and here would be the pattern for 1. Okay, so that takes care of B. Now for C, it says represent the number of dots or squares of the patterns as a list. Well, actually, we already did that. It's 25, 21, 17, 13, 9, 5, and 1. So the list is just going to be the list of numbers. And it appears that each time, you may notice this once you actually have this listed out. You may have already noticed it with the pictures, but what's happening here is it looks like we are subtracting 4 each time. Okay, this is what's called a common difference. So we are subtracting 4 every time, and then we get down to that final value of 1. Okay. Now, if we throw this in a table, we started with 25, and then we kept on subtracting 4 each time. So 17, 13, 9, 5, and 1 may seem a little bit repetitive, right? But now we're just taking this numerical sequence and we're putting it in a table. And in the future, this is going to help us with actually graphing it. Now, 25 is the first term. It's the first one that actually shows up in the picture up here. So we call that the first term. 21, therefore, is the second term. Then we have the third term, fourth term, fifth term, sixth term, seventh term. Normally, we would have an eighth term, but here we do not because you can't draw negative dots, right? So this is actually what's called a finite sequence. This sequence ends. You don't need that eighth box there. Now let's take a look at this guy. So for example, 2, we have, looks like we have 1 square here. We have 4 here. We have 9 here. I like to just add things up so I can see that, see if I can see any, like what's going on with the numbers. I think this one actually may be a little bit easier to see if you draw the picture though, right? So this is a 1 by 1. This is a 2 by 2, right? This is a 3 by 3. So I think the next one might be a 4 by 4. I think that makes sense, right? I'm just kind of basing that off of a pattern. So a 4 by 4. And if you count those up, that's going to be 16 total squares. And next, you probably guessed it, it's going to be a 5 by 5, right? Again, just based on this pattern that I'm observing here. 1, 2, 3, 4. Let's throw one more in there. So that ends up being a 5 by 5. So that's going to end up being 25. So that's 2 more. I think the directions tell us to draw the next 3 patterns. I guess I'm jumping ahead and doing B right here. But the last one would be a 6 by 6. And I heard a lot of people in class say, oh, I'm running out of room. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's going to be your 6 by 6. And if you total those up, you will have 36 total squares. So if you were to describe this, it looks like we are adding a row and a column to get to the next term in the sequence. That's one way you could describe it. Looks like each time we're adding a row on top and a column on the side. For B, we already did that. We drew the pictures. And then for C, what's it looking for? It wants our numerical sequence, which we already kind of did as well, right? So our numerical sequence here is going to be 1, 4, 9, 16. It's just going to be the total number of squares, right? 25 and 36. So that's our numerical sequence. Now, if we're going to throw this down into a table, we have our first term, our second term, our third term, our fourth term, our fifth term, our sixth term, our seventh term, etc. This guy's going to keep on going, right? So we have 1, 4, 9, 16. You may be noticing now that it is the term number squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. This would be 49, etc. And that's your table. Now, for example 3, we have the sequence 3, 5, 7, 9. And we asked, what do you notice about this sequence? And we want to encourage you guys that there are no wrong answers here. We want to encourage you guys to take risks. In class, though, what the majority of people jumped up and saw at first was you are adding by 2 each time. This is called a common difference because we are adding by the same number each time. Some others in class said they noticed you are skipping the even numbers and you are just working with the odd numbers. Okay, so those are a couple of things. If we asked you to make a picture of the integers, what would come to mind? Well, that's kind of on you. You can kind of look back at those examples up above, see if you can come up with something. And then for C, what would the next 3 numbers in the sequence be? Well, if we continue with the same pattern that's happening here, pretty sure we'd agree that this would be 11, 13, and 15. If we continue that plus 2, plus 2, plus 2, plus 2, plus 2, that common difference, okay? Now, if you are watching this, this is the conclusion of your first notes that you've taken in IM1, so it's very likely this is your first time going through the notes. We are always going to have extra resources down at the bottom here each day. I would highly encourage you to get used to watching some Khan Academy videos. You might want to take a look at that Khan Academy sequences video. And that concludes today's notes. Go give that self-assessment a try. Make sure you watch that self-assessment video. Good job.